Forensic science is a multidisciplinary field that applies scientific principles and techniques to solve crimes and legal issues, encompassing a wide range of disciplines, including biology, chemistry, physics, and computer science. The goal of forensic science is to provide objective and reliable information that can aid in the investigation and prosecution of criminal cases. The roots of forensic science can be traced back to ancient civilizations. In ancient China, forensic techniques were utilized as early as the 3rd century. The famous Chinese physician Song Si wrote a book titled, The Washing Away of Wrongs, which included guidelines on how to investigate deaths and identify causes of death based on physical evidence. During the late 19th century, forensic science began to develop into a formal discipline. In 1892, Sir Francis Galton published the first book on fingerprint analysis, establishing fingerprints as a unique identifier for individuals. Shortly after, in 1893, Hans Gross published Handbuch für Untersuchungsrichter, Polizeibeamte, Kriminalbeamte, which laid the groundwork for criminalistics as a scientific discipline. The 20th century saw significant advancements in forensic science, particularly with the introduction of DNA profiling in the 1980s, which revolutionized the field by allowing forensic scientists to identify individuals with unprecedented accuracy based on their genetic material. Forensic science is composed of several key disciplines, each specializing in different types of evidence and analysis methods. Forensic biology involves the analysis of biological evidence, such as blood, saliva, hair, and other bodily fluids. Forensic biologists utilize techniques such as DNA analysis, serology, and microscopy to identify individuals and determine the biological origin of evidence. DNA profiling, in particular, has become a cornerstone of forensic biology, enabling the identification of suspects and victims in criminal cases. Forensic chemistry focuses on the analysis of chemical substances, including drugs, explosives, and toxic materials. Forensic chemists use techniques such as chromatography, mass spectrometry, and spectroscopy to identify and quantify substances found at crime scenes. This discipline plays a crucial role in drug-related investigations and cases involving chemical exposure. Forensic toxicology is the study of the effects of drugs and poisons on the human body, where toxicologists analyze biological samples, such as blood and urine, to determine the presence of toxic substances. This information can be vital in cases of overdose, poisoning, or impaired driving. Forensic anthropology involves the examination of human skeletal remains to determine the identity, age, sex, and ancestry of deceased individuals. Forensic anthropologists apply their knowledge of human osteology and archaeology to assist law enforcement in cases involving unidentified remains. Forensic odontology is the study of dental records and bite marks to identify individuals, allowing forensic odontologists to match dental records to remains and analyze bite marks found on victims or surfaces to provide evidence in assault cases. Forensic entomology utilizes the study of insects to estimate the time of death in homicide cases, as forensic entomologists can provide valuable insights into the post-mortem interval by analyzing the life cycles of insects found on decomposing bodies. Finally, digital forensics involves the recovery and analysis of data from electronic devices, such as computers, smartphones, and servers, where digital forensic experts examine digital evidence to uncover information related to cybercrimes, fraud, and other criminal activities. The forensic investigation process comprises several key steps, starting with the thorough examination of the crime scene. Crime scene investigators, CSs, document the scene, collect evidence, and ensure that the scene is preserved for analysis, including taking photographs, sketching the layout, and identifying potential sources of evidence. Proper evidence collection is critical to the integrity of the investigation, which is why forensic scientists follow strict protocols to ensure that evidence is collected, labeled, and stored correctly. This includes using gloves, sterile containers, and appropriate tools to avoid contamination. Once collected, evidence must be preserved to maintain its integrity, with forensic scientists employing various techniques, such as refrigeration, freezing, or chemical preservation, to prevent degradation or contamination. After evidence is collected and preserved, it is sent to forensic laboratories for analysis, where forensic scientists utilize a range of analytical techniques, including microscopy, chromatography, and spectrometry, to examine the evidence and draw conclusions. Finally, forensic scientists often prepare detailed reports summarizing their findings and may be called to testify in court as expert witnesses, explaining their methodologies and results to judges and juries. Forensic science plays a critical role in the criminal justice system by providing objective and scientific evidence that can aid in solving crimes and securing convictions. The use of forensic evidence can help establish timelines, identify suspects, and exonerate innocent individuals. Forensic science has been instrumental in solving numerous high-profile cases, with the analysis of DNA evidence, fingerprints, and other physical evidence leading to the identification and conviction of many criminals. It can also provide leads in cold cases, helping law enforcement agencies revisit unsolved crimes. Moreover, the use of forensic science helps ensure that justice is served by providing accurate and reliable evidence, which is particularly important in cases where eyewitness testimony may be unreliable or where circumstantial evidence alone is insufficient for a conviction. Additionally, forensic science has played a vital role in exonerating individuals wrongfully convicted of crimes. Advances in DNA analysis have led to the release of many innocent people who were convicted based on flawed evidence or witness testimony, with organizations such as the Innocence Project working to identify and exonerate wrongfully convicted individuals using forensic evidence. Despite its many advancements, forensic science faces several challenges that can impact its effectiveness in the criminal justice system. One significant challenge is the potential for contamination of evidence, as improper handling, storage, or transportation can compromise its integrity and lead to unreliable results. Strict protocols must be followed to minimize the risk of contamination. Human error is another challenge, as forensic analysis is performed by human experts, introducing the possibility of error through misinterpretation of results, mistakes in analysis, or bias. Ongoing training and adherence to best practices are essential to mitigate these risks. Many forensic laboratories also face resource limitations, including funding, staffing, and equipment shortages, which can lead to backlogs in evidence analysis, delaying justice for victims and suspects alike. Legal and ethical issues surrounding the use of forensic evidence in court raise important questions about the admissibility of certain types of evidence, the potential for bias, and the implications of privacy rights in digital forensics. As technology continues to advance, the future of forensic science looks promising, with several emerging trends and developments shaping the field. Advancements in DNA analysis technology are continually evolving, leading to more accurate and efficient methods of identifying individuals. Techniques such as next-generation sequencing, NGS, are becoming more accessible, allowing forensic scientists to analyze complex samples with greater precision. The integration of artificial intelligence, AI, into forensic science is also on the rise, enabling faster and more accurate analysis of large datasets. AI algorithms can assist in pattern recognition, predictive modeling, and automating routine tasks, allowing forensic scientists to focus on more complex analyses. Furthermore, as technology advances, digital forensics will continue to evolve, presenting new challenges and opportunities for forensic investigators. The proliferation of smart devices, cloud computing, and the Internet of Things, IoT, necessitates the development of effective methods for recovering and analyzing data from these sources. Finally, the future of forensic science will likely see increased collaboration between various disciplines, including law enforcement, legal professionals, and scientists. Interdisciplinary approaches can enhance the effectiveness of investigations and ensure that forensic evidence is used appropriately in the criminal justice system. In conclusion, forensic science is a vital component of the criminal justice system, providing essential tools and techniques for solving crimes and ensuring justice. As the field continues to evolve, Advancements in technology and interdisciplinary collaboration will further enhance the capabilities of forensic scientists. While challenges remain, the ongoing commitment to scientific rigor and ethical standards will ensure that forensic science remains a critical ally in the pursuit of truth and justice.